If you put it where the sun is, it would loosen up to the circle of Jupiter, a monster totally shaky and going to explode. They are among the most prominent impacts of radio energy in the entire universe, delivering more energy than a billion suns. Bug Jew, or frightening crawly Jew, is a red Goliath star. In the event that you put it where the sun is, it would connect with the orbit of Jupiter, monstrous, completely unpredictable, and going to explode. When we consider stars, we most likely imagine minimal glow things in the night sky. Basically, this is how we see them from down here on the planet, but stars are something completely different. Actually, one of the most prominent stars, Betelgeuse, is much greater than our sun. For very much a long time, this star has confused analysts. However, recently, something additional upsetting has been happening with Betelgeuse, making scientists and other well-educated individuals incredibly concerned. Join us in this video as we explore the marvelous new findings about Betelgeuse, its approaching obliteration exactly as expected by the James Webb Space Telescope, and how this new discovery will impact our universe and our lives here on Earth, as explained by physicist Michio Kaku. Betelgeuse is a huge marvel, a gigantic star that has fascinated astronomers for such a long time. A Greek astronomer named Antonius was the first to discover it. This star is so giant that it can be viewed in the night sky from Earth, particularly during winter. If you're into cosmology, you've probably seen or heard of this star. The blushing orange star marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and, so far, quite possibly one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay consistent. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one we should investigate. Some of Betelgeuse's specific properties are interesting. The majority of the stars you see in the night sky are far from Earth. The closest star is 4.2 light-years from Earth. In case you don't perceive how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been shown that light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is comparable to 1 light year, expecting you crunch the numbers. You'll have billions of miles. So, when we say the closest star is 4.2 light years away, it means it is billions of miles from Earth. Anyway, contemplate this. Some stars are significantly farther, and Betelgeuse is one of them. Betelgeuse is found around 600 light-years from Earth. So if you somehow manage to go to it at the speed of light, it would still take 600 years. We can't move that quickly, not even our fastest space rockets. Yet, this star can still shine so brilliantly in our sky. If you're considering how Betelgeuse can be so brilliant regardless of its distance, that's a result of its unique qualities like size and brightness. Betelgeuse is multiple times greater than our sun. Its radius is acknowledged to be, on different occasions, that of the sun. Tragically, it appears as a disk in space when using modern telescopes, while various stars show up as little points of light. This is thought to be an impact of the reactions at the outer layer of its atmosphere. With regards to mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space experts. 1 solar mass is comparable to 2 by 10 to the power of 30 kilograms. Scientists can't choose the specific mass of Betelgeuse because there are no other planetary bodies circling around it to compare it with, and obviously we can't measure it directly from here on Earth. However, this makes Betelgeuse, at least on different occasions, heavier than our sun. The brightness of Betelgeuse goes from magnitude +0 to +1.6. In more common terms, Betelgeuse is on numerous occasions more brilliant than our sun. No surprise it was nicknamed a red Goliath. However, the brightness of Betelgeuse doesn't stay consistent. It fluctuates. This change is due to its pulsations. In other words, Betelgeuse grows and contracts. When it develops, it gets brighter. When it contracts, it dims. This cycle can endure for 10 to 100 days or even significantly longer. A novel property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is far more grounded than at the typical surface. Anyway, the downside is that these strong magnetic spots frustrate the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots compared to our Sun makes sense of why it is cooler than our Sun, regardless of its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is on different occasions more grounded than that of the Sun. This field is the reason that when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be in circles or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy radiated by the star and its weak red tone. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 10 million years ago, much like our Sun. Over time, the color began changing to orange, red, and then, around 100,000 years ago, it slowly started transforming into the red star we know today. This fact has led scientists to believe that the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the Sun. It would have been a furious contender to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and related to the naked eye around evening time is extremely striking. Our Sun is only 8.3 light-minutes from Earth. That's why it's so strong. If Betelgeuse were just somewhat closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would consume or displace the Earth and the other 4 planets near it because of its gigantic size. Besides, regardless of whether it were to match the Sun in size, it would still discharge more radiation. Betelgeuse, also known as Bug Jew, is a very giant star located in the constellation Orion, about 600 light-years from Earth. Its gigantic size is one of its most striking components. It is multiple times greater than our Sun in terms of radius and could easily incorporate the orbit of Jupiter if placed at the center of our solar system. This legendary size allows Betelgeuse to appear as a disk instead of a point of light when viewed through powerful telescopes. In contrast to most other stars, despite its gigantic size, Betelgeuse isn't the most enormous star. Its mass ranges from around 12 to 19 times that of the Sun. This variation in mass estimates is due to the challenges in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Indeed, even at its lower estimated mass, Betelgeuse remains a huge celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates consistently over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can ultimately be up to 1,000 times more brilliant than our Sun. This fluctuation is ascribed to its pulsations, intermittent expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for months, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct red color typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, displaying dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive, vigorous star, but it will eventually meet its end in a spectacular supernova. Betelgeuse is an enormous star approaching the end of its life, and its possible fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a cosmic explosion. A catastrophic blast that marks the death of a massive star. The power of a supernova is strong enough to briefly outshine an entire galaxy. This phenomenon could potentially send shock waves through space, and it's possible Betelgeuse will do just that once its time has come. It's an event that will likely be visible from Earth and might dramatically affect our solar system, but it's not expected to happen immediately. Scientists are still unsure of the precise timing of Betelgeuse's demise. However, with advanced instruments such as the James Webb Space Telescope, we are closer to understanding when it might happen and how its death will shape the cosmos. Betelgeuse, or Betelgeuse, is a remarkable example of a massive star nearing the end of its life cycle, and it provides astronomers with a fascinating window into the life and death of stars. This red giant, part of the Orion constellation, is one of the most studied stars in the night sky, not only because of its impressive size and brightness, but also because it offers insight into stellar evolution. As Betelgeuse nears the end of its life, it undergoes extreme changes that can teach us much about the fate of massive stars and even the evolution of galaxies. One of the key aspects of Betelgeuse that makes it so captivating is the fact that it is a variable star. It belongs to a category of stars that changes in brightness over time. Specifically, Betelgeuse is a semi-regular variable star, meaning its brightness fluctuates at irregular intervals. These variations are not only visually striking, but also provide valuable information about the star's internal structure and processes. As it expands and contracts, Betelgeuse sheds layers of its outer atmosphere, and this is responsible for some of its variability. The pulsations are thought to be linked to the complex nuclear processes occurring in its core as it struggles with the depletion of hydrogen fuel. As Betelgeuse expands, its surface cools and takes on a redder hue, which is typical of a red giant. The cooler temperatures of red giants are associated with the late stages of stellar evolution when a star has exhausted much of its hydrogen fuel and is beginning to burn heavier elements like helium and carbon in its core. This process causes the star to grow larger in size, and Betelgeuse has swollen to such an extent that if placed in the center of our solar system, it would extend beyond the orbit of Mars, consuming the inner planets, including Earth. However, it is important to note that Betelgeuse is still in the relatively early stages of this phase, and its eventual death will be far more dramatic. One of the most intriguing aspects of Betelgeuse's behavior is its erratic pulsations. These pulsations are not just about size. They also impact the star's luminosity, leading to significant shifts in brightness. This is where the study of the star's fluctuations becomes important for scientists, who can use this data to better understand the processes happening inside the star. The nature of these pulsations is complex and still a subject of ongoing research, but they provide a detailed picture of how a star like Betelgeuse behaves as it nears the end of its life cycle. In addition to its pulsations, Betelgeuse has another unusual feature. It is surrounded by a thick cloud of gas and dust. This surrounding nebula contributes to the star's dimming at times, as the material blocks some of the light that would otherwise escape into space. The nebula is a product of the star's extreme mass loss as it sheds material during its later stages of evolution. This outflow of material is also what will eventually lead to the star's transformation into a supernova. As Betelgeuse loses mass, it moves closer to the critical point where it can no longer support its immense gravitational pull, triggering the catastrophic collapse that will lead to a supernova explosion. Betelgeuse's future as a supernova has been a point of great interest. When it eventually reaches the end of its fuel supply, the star will no longer be able to sustain the nuclear fusion reactions in its core. As a result, the core will collapse under its own gravity, leading to an incredibly violent explosion. This supernova will release an enormous amount of energy, so much so that for a brief period, the explosion will outshine the entire galaxy. The shock wave from this explosion will travel through space, potentially affecting nearby objects. Though Betelgeuse is located about 600 light-years away, the explosion could still have significant effects on its surrounding environment. For example, it could trigger the formation of new stars in nearby gas clouds or even affect the interstellar medium in its region of space. The collapse of Betelgeuse's core will result in the creation of a neutron star or possibly a black hole, depending on the exact mass of the star at the time of its death. The outcome is not entirely certain, but it is clear that Betelgeuse will leave behind a fascinating remnant that will continue to influence the cosmos long after its death. The explosion will likely be visible from Earth, giving future generations an opportunity to witness one of the most spectacular events in the universe. While Betelgeuse is still far from reaching the end of its life, It is undoubtedly one of the most anticipated astronomical events. Observations from telescopes like the Hubble Space Telescope and the James Webb Space Telescope have provided astronomers with unprecedented views of the star's behavior, helping to refine models of stellar evolution. As we continue to monitor Betelgeuse and other massive stars, we gain not only a deeper understanding of the cosmos but also insight into the ultimate fate of stars like our Sun. However, unlike Betelgeuse, our Sun will undergo a much less dramatic end, transitioning into a white dwarf after expanding into a red giant and shedding its outer layers. Betelgeuse serves as a reminder of the immense power and complexity of stars. These celestial bodies are not static. They undergo dynamic changes that can affect not just their own systems but also the surrounding space. As scientists continue to monitor Betelgeuse's behavior, they will learn more about the mechanics of stellar death, the formation of black holes, and the cosmic recycling that occurs when a star dies. In the end, the legacy of Betelgeuse will live on, not only in the supernova explosion but also in the ongoing study of stellar evolution and the profound forces shaping the universe.